Today, we're going to kick off a Spring Boot playlist, at the end of which you should know pretty much everything you need to know to start creating your backend APIs using Spring Boot. In this video, we will review the structure of an existing Spring Boot application. That way we have a sense of what our target's going to be when we build this application from scratch. In the next video, we'll talk about entities and entity relationships, how they map to our database. We'll talk about repositories, basically how we transact with our database. We'll talk about controllers, how we create our REST endpoints, and we will test those out in this video with Postman. And we'll talk about services where we will have any additional business logic that needs to be done between our REST controller and our repository. And we'll talk a little bit about DTOs or data transfer objects, scheduling, Spring Boot properties and profiles, and our build script. And that's about it. Entities are plain old Java objects, or POJOs, which map directly to a database table. And as you would expect, the class properties map directly to the columns of that database table. So here we can define table properties, and we can define column properties, and also constraints. We can define indexes, foreign key relationships, and so on. This particular database application is modeling the NFL. So we have, let's look at some of our entities here. We have teams, positions, players, coaches. We even have matches and awards. So everyone's pretty familiar with the NFL or how football games work. And I think this is kind of a good example to see how our entities relate to each other in terms of the Spring Boot application. So let's go ahead and look at the player class here. This player class we're going to mark as an entity. That is telling Spring Boot that this is mapping to a database table. And then we are going to specify table properties using the @table annotation. So we'll give it a name, and we'll even define some indexes that we want on that table. So the player is going to have some properties, and these are going to map to database tables. We're going to have an ID, we're going to have a first name, last name, position, team, received awards, and teams played for, and whether or not they are franchise tagged. So we're kind of covering as many different types of properties and as many different types of relational mappings with other tables as we can in this example. So let's break down the properties of the player. We have a property called ID, and we're going to tell Spring that this is our primary key. This is our ID. So we use the ID tag to designate that. And then we're going to specify that we want this to be an identity column. This is going to tell Spring to tell the database that we want this to be auto-generated. Now let's look at the first name. We're going to tell Spring that we have a length of 50 characters and that it's not nullable, meaning that it has to be required. If not, then database is going to obviously throw an error. Same thing with last name. We're going to have a position, a team, awards, and teams played for, as well as franchise tag. Now notice a few things here. Franchise tag does not have a column annotation. That's okay. We actually don't need the column annotation if we're not going to change any of the default properties. So as we'll see in our database, we're still going to have a column created, and I'll show you what that looks like. Now, what does this entity actually look like in the database? Let's jump over to MySQL Workbench for a second, and we can see that from our LU player table, which is the name of the database table we gave it in Spring Boot, we have our columns here: ID, team ID, first name, last name, position ID, franchise tag. You'll note that we didn't designate certain column names. We could have. So we could have come in here and said, name, we want this to be last name. But Spring Boot is going to automatically give us a default column name of last name, just like that. So we have ID, first name, last name, franchise tagged, You can see that first name and last name are not nullable, just as we designated. And we can see position ID and team ID. But you note in our player entity, we don't just have simple longs or integers here for the position ID or team ID. We're actually referencing the related entity, right? So we have a position and we have a team. So Spring is capable of actually joining that entity automatically for us. So we'll see that here in a second. We can specify how we want Spring to join that, whether we want it to be eagerly fetched, so joined whenever this entity is queried, or lazily fetched to where it's not joined when this entity is fetched, and it's only joined later if we need the information about it. You will also note that in many-to-one relationships, the default fetch type is eager, while in one-to-many relationships, the default is lazy. And this makes a lot of sense because it's very easy to join many-to-one relationships, right? Because you just really need a join statement onto your select statement. You don't need to perform additional select statements. It's a little bit more complex when you're trying to also query one-to-many relationships because you're now having to do an additional query in most instances. We'll find out there's an exception to that with Spring Boot version 3, where we can now fetch multiple bags. Let's go ahead and take a quick look at what a Postman request would look like for this entity. So I'm going to open up Postman. I'm going to go to my player request here, and I'm just going to hit send, and you can see here's our response. So here are all the players in our database. We have Tom Brady, the position, and the team. And you will note that those are all eagerly fetched properties. So we have many-to-one. Again, the default is eager. So we're going to see that in our JSON response. Dak Prescott, quarterback, team, Dallas Cowboys. So you see, because we fetched the whole entity, we can see all the properties of that entity instead of just having, the database column. So that is really cool. Now, how do these entities relate to one another? Let's look at our EER diagram. So we have our player table, right? And each player is assigned a position. That position is played by many players, right? This is a many-to-one relationship. This is the many side here, and we have the one side here. So one position is played by many players. So when we define this relationship in our player table, this is the owning entity of the relationship because we have that reference to the position here. So that's why it is a many-to-one relationship. We only have one position within our player table. Same goes for our team. We have only one team to go with the player. And we also had the other property of all the teams that they have played for. So in that case, that is a many-to-many relationship in which we've got many teams which have many players, and many of those players have played on many teams. So that is a many-to-many relationship. We'll get more into detail on this in a subsequent video. Let's take a look at that in our SpringBoot project. So we have our player entity. Let's jump over to position. Now position, we could have a property here that lists all of the players that play that position, but in this case, it's not really necessary. The position is really just its own little entity. It doesn't really care that much about the players. So we're just going to have it defined as a one-sided relationship or unidirectional relationship. Team, on the other hand, it would be very reasonable and makes a lot of sense that the team would also know about all of the players that play for the team. So this is a bidirectional relationship. We're going to have a many-to-one side on the player entity, and then on the team entity, we are going to have a one-to-many relationship. So a team is going to have a roster. That's what this property is called. A roster here is a list or a set of players that play for the team. So again, let's jump back to our Postman and we can see that a player plays for this particular team. Now, what happens if we query our team endpoint? Let's look at one particular team and we see that we have our full roster here, which we only have one player in our database that plays for the team at the moment. But if we had more, we would see the whole roster. So our entity package and our project might have sub-packages categorizing them. But for the most part, all of our classes within our entity packages are going to be mapped to database tables. That is the whole point of this package. That's why we kind of encapsulate that into this package. Now, any entity that we want to be able to fetch from the database, we're going to have a repositories package. Within this package, let's look at the player repository. This particular class is going to be marked as a repository using the annotation. And by default, we're already going to have most of the methods that we really need. We need a save method, we need a find by ID method, we need a find all method, we need a delete by ID method. If I look at all of the methods that I can override, I can see that we have all of those methods already implemented by Spring Boot. Now we can, of course, override them if we would like, and that's what I did in this case because I wanted to also talk about the entity graph. Now, an entity graph allows you to define for a particular repository method what all we want to be fetched in regards to that entity that we are returning. So in this case, in our player repository, I'm going to override the find by ID method as well as the find all method. Now, why am I doing this? Let's look at the find all method and let's take out the entity graph. And then let's go ahead and restart our Spring Boot application here. And I'm going to hop over to Postman. And let's send this request. And let's look at what Spring Boot did with the database. So as you can see, it ran a select statement from our player table, which is expected. And then because we have certain properties eagerly fetched, like position and team, it's now going to run a select statement for every player that it fetched. So we have a select statement for position, we have a select statement for team, another one for team, another one for position. We're going to do this for every player in our database so that we can ensure that all those eagerly fetched properties are there in our response. But there's a much better way to do this, right? With join statements. That is where the entity graph comes in handy. We can tell Spring, hey, make sure to fetch those eagerly fetched properties as join statements in the entity, in the original request for the entity. So let's go ahead and run that again. So let's test it out again. Go ahead and hit go. And now we have the same response. The only difference is we only ran one select statement. So this is why it's really good to show the logging, especially when you're developing. So you can see what Hibernate is actually requesting from the database. If you imagine that we had thousands and thousands of players, you wouldn't want thousands of select statements. You just want the one select statement with the joins. Now, how is Postman getting this data? Well, that's from our REST controllers. So we're going to see that in the controllers package here. So let's look at that player controller. So in the player controller, we're going to see an annotation called REST controller. This is telling Spring, hey, this is a class that is going to have REST endpoints and that will be defined. Please create a REST endpoint for this. And at the class level, we can specify a request mapping. This kind of simplifies the rest of the methods within this class. because we don't have to designate an endpoint for every method. We can do this at the class level. Now in the method, we can alter the path to the endpoint, as we'll see with our findById method. So let's take a look at the position controller because it's quite simple. Generally speaking, you're going to have a controller dedicated to a particular entity, and that way, you don't kind of overcomplicate any of your controllers. It's quite clear to any other developer what the purpose of that controller is. So in this case, we have a position controller, which is obviously dedicated to returning requests about the position entity. So I'm going to specify a request mapping of /position. So any request that comes in to our URL with the /position is going to be routed here to the position controller. Now I can have methods that I can annotate for different HTTP requests. So I can have a get mapping, obviously, and I can have all of our other methods, post, put, patch, delete. In this case, I'm just going to show off the get mapping because it's quite simple. So we have a find all method. I'm just calling it find all. It could be called anything, but I'm using find all because that is the method from the repository that I'm calling to basically fetch all of the positions. And I don't specify any additional parameters to the path. So that means that the REST endpoint is simply position. And if I call the get method for that endpoint, I'm going to return the results for the find all method. So let's see what that looks like. Let's go over to our position endpoint here, and I'm just going to call that position endpoint and see what happens. Here we go. We have the response of all the positions that are in our database. So position just has an ID and a name. We have QB, quarterback, running back, and wide receiver. Now, what else can I do? I also have another get mapping with a /ID. So this is pretty typical if you also specify an ID within the path that you are only going to return the entity for the ID that you provided. So in that case, that's what I do here with calling a findById method. And let's see what that looks like. So if I specify, let's do QB and hit send now. Now I'm calling the get method for that findById. Now in our player controller, I have other HTTP methods defined. I have a post mapping, I have a put mapping, I have a patch mapping, and a delete mapping. I'm not going to get into each of these in this particular video. We'll go into each of those in a subsequent video, but I will just show you that what I'm doing here in the REST controller is everything in this particular class is just dedicated to receiving and sending the HTTP response. I'm not putting any business logic in here or any database logic for that matter. That way we really kind of encapsulate the logic into the appropriate places within our project. And this is nice and clean. We don't have a huge class with, business logic everywhere. So every method I can, clearly see that I have a get mapping, two get mappings, one for find all, one for findById. I have a post mapping, which is going to take in a request body. So that'd be a JSON object representing a player. And then I'm going to just simply save that and return the response of that save. So that save is also going to return the resulting player, which is going to include the newly generated, auto-generated ID, right? And as you notice that each of these controller methods are interacting with a player service. So generally speaking, you want to have all your business logic into a service, and the service is what is going to be interacting with your database repository. That way, if you need to perform any additional logic to the entities that are returned from your repository, you can do that in the service, and that takes care of it all. That way you can interact with your service from other areas of your project. So your controller is one area. You might also have other areas like scheduled tasks that also are going to interact with those same service methods. So let's just take a quick look at a position. Let's go back to position here, and let's look at the position service, because this is going to be quite simple. Now, the position service is going to inject the instance of our position repository. We do that right here in the constructor. And here we're just kind of repeating the methods from the repository that we want to be able to use in other areas of the application. So really that's just our find all and our find by ID, right? Because that's what we're using in our controller. Now, if my controller is also going to support other HTTP methods like delete or post, then we can also create those methods here in the service. Now, again, I don't want to get too in-depth into each of these, and I want this to be a relatively short video. So let's try to wrap it up a little bit. Let's talk a little bit about configuration. So your project's likely going to have a config folder. You might have security configuration in here, which we'll talk about in a later video. But you might also have configuration for how you want your JSON to be formatted. You might have exception handler. You might have scheduling configuration, and you might even have a class for initializing database data, which I have here. This way I can, every time that I drop and recreate the database, if I want to add additional entries into my database tables, I can do that within this initialization script right here, where I have a whole bunch of SQL to just populate entries into our database. So that way we can kind of see how they interact. Another thing that I'm going to touch on real quick is our Spring Boot application properties. Generally always have a application.properties file in your resources folder. This is where you're going to define your properties for your project. And what's really cool is that you can have different profiles for the project too, that you can easily swap between. So if I specify certain profiles, it's also going to load the property sheets for those profiles. So in this case, I have a profile for API as well as scheduling and a profile for local. And I might also later have a profile for production. So that way I can easily kind of specify, what database am I connecting to for my local profile versus when I actually export this project, I might be using the production profile. So let's take a quick look into that. So I'm going to define a couple top-level properties here. Basically, that this is not a web application, which is obviously going to be overridden by my API profile. This just allows me to create different profiles where I don't need to specify this, as well as not having a port. This is an API project. Let's jump right into the API settings. So here we're going to define like how our API is going to run. I have it defined as just running on my localhost and only listening to localhost connections at port 8080. That's why I've been connecting to localhost 8080 and Postman. That's where the application is listening to, as well as a context path of /API. So that's why I also specify API and then the Git mapping and then the whatever other endpoint I have within that REST controller. Let's also jump into our local properties, where I'm going to specify my data source URL. This is where my MySQL database is running. And I have a username and password defined here. Now you might want to do this as environmental variables later so that you're not actually showing that. Properties sheet can look up your environmental variables very easily. You can also specify properties within your Gradle.properties. I'm also going to say that I want to use the MySQL 8 dialect, and then a bunch of logging properties for the most part here. So I have, I want it to show me the SQL. Now I might not really want that to be printing in production, so that's why I have that defined here in my local properties. And then that way I can also see what the value is that is being put in, that is being binded into those prepared statements. I'm setting the logging level for everything within my project to trace so I can see all of my logs. Now when this is in production, I'm not going to need that to be a trace, right? I'm probably just going to have that at info level. And then you can specify a logging pattern, and that's about it. I'll take a quick look at my scheduling properties. Here I'm just basically defining that I want it to be enabled. And the last thing that we'll get into is just this is a Gradle project. You can also have a Maven project. Those are the two main build scripts that you might have. And here I'm basically just defining the dependencies of the project. So the last thing I said I would talk about are entity DTOs and scheduling properties. Those are the last two packages here. Entity DTOs, I'm not going to really cover too much in this video, but I will just say that you're just going to have essentially copies of your entities, other POJOs that represent different views that you're going to be using to transfer information. So for example, I might have a player DTO that doesn't have as much personal information. And maybe I will use that DTO instead of the entity itself when I'm transferring information for someone who has a lower privilege or permission. So that's what you would use DTOs for. Lastly, I like to have a package for scheduled methods. And in here, I can just kind of define a method that I want to be scheduled at either a certain interval rate or on certain days of the week or once a month. Those are things that I can define in the scheduled package here. So we covered a lot of grounds in this video just on the whole structure of the application. In the next videos, we're going to start from scratch and slowly build up to learn all of these things that I kind of broadly covered. I know I went into a little bit of detail on the player entity, just because I wanted to go ahead and give you a sense of how that mapping looks like to a database table, but I don't want to go too in depth. So we will start with more simpler entities and start building relationships in the next video. If you found this video useful, please consider liking it and make sure to subscribe so that you get notifications for all the next videos in this Spring Boot playlist. I'm so excited I want to just go into detail on this whole project in this one video, but I want to break this up into segments so that we can really kind of focus on each part of the project. And I want you to learn as much as you can in as quick of a time frame as possible. And thanks for joining me today.